Okay, Art22. Welcome to the last lecture of the week where we're going to be still working with our pixels array. This is one of my favorite examples. I think it's just, in the scheme of things, relatively simple based on what we've seen in the last two lectures. Not much else is being added, but we're going to get a very interesting and rich result, and a result that looks very complex, which is something that's always a win, I think. So what we're going to be doing is we're going to be combining our work with the pixel array, which again is the array that stores all of the color values for every single pixel on our display. And we're going to be combining that with using an image and then manipulating the pixels inside of that image. This is probably one of my favorite types of things to do in creative coding or processing, is take some existing image, because you get so much for free. Like, the world is interesting, so images of it are usually interesting too. And so then to take that and then use computer code to adapt it and modify it and change it is just a lot of fun, and some interesting results come out of it. So let us get a few things set up with our pixel array first in our image, and then we'll check back in to see what exactly we're going to be doing to sync the image and the pixel array up together. So first things first, let's get rolling. Okay, so we got a new sketch here, week 4, Class2B. Now, like a previous example, you're going to need to get an image from our resources repo on GitHub. In this case, it is this image here, watercolor.jpg. This is a Mark Hirsch original. You all know that I'm an incredible analog artist. No, this is just something fun, and I like colors, so this is what happened. But this is going to be the image that we're working with today. This is going to be the image that we're going to start to mess with all the pixels inside of it. So make sure that you get that image from the repo and put it into a data folder next to your sketch. Okay, so let's get all the kind of prerequisites here. Doing what we always do, taking over the world. If you got that reference, I am happy. Okay, so I believe this image is 800 by 800. So let's make the size of our screen the same. Okay, and then let's go ahead and load this image, because we're going to need to use it. So if you remember, we load an image by creating a pimage variable. I'm going to call it image. And then let's actually load our specific image file into this. So let's say image equals load image, and then we just need to tell it the file name, which in this case is watercolor with a capital C .jpg. There we go. Great. All right, and the other thing I want to do is just set up our nested loop that we learned about in the last lecture, which is again our way to go through all of the pixels in our display, but in terms of X and Y, not in terms of the index in the array. So let's just write that out again, just to kind of get another go at it here. So first things first, let's load our pixels. We always got to do that. Okay. Now let's get our for loops going here. So first one is going to be our X, right? So we're going to say int X equals 0. So we're going to start X at 0, far left. We're going to go across the entire screen, all the way up until width. And we're going to increase by 1. Now, because we're scanning left to right, we also need to scan top to bottom. So we're going to say for int y equals 0, y less than width, y plus plus. All right, and now let's make sure we get our other curly brackets in line. Great. All right, let's not Well, let's do one thing before we talk about the rest of the stuff. We know that by going through all of our pixels in this nested loop version where we're using X and Y, we know that we're going to need to then convert that to get the index into the array, just like we did last lecture. Nothing different here. So just to get that ready to go for us, I'm going to say int index equals our magic formula X plus Y times width. So remember, this is pure magic. Okay. And I'll just make one more comment. Nested loop to go to, let's say I like the idea of scanning. It makes sense to me. To scan through all pixels. Great. Let's be really clear. Through all pixel locations, because we're dealing with X and Y. And then let's just not forget down here, after what we do whatever we're doing, we should also update our pixels. Very cool. Okay, so let's switch over here just to see what we're going to be doing. All right, so the way that this is going to work, we have our image file, and we have our pixels, the array of pixels. And we need a way to sync these things together. So the way that this works is we're basically going to look at our image and grab, let's say for that first pixel in our image, if we look at our image on the top left, we're going to grab that color, which if you remember the image, it has like a white background. So we're going to grab that white pixel in the top left corner, I guess this way, reversed from you, in the top left corner. Okay, we're going to be like, okay, that color is white. So we need to then set the first pixel of our window to be white as well. Let's see, let me draw this out here. So we have an image. Here's our image. It has some watercolory stuff in here. Okay, and then we have our processing window, like that. Okay, so what we're gonna do with our nested loop here is we're gonna say, okay, get to the pixel that's at location x equals 0, y equals 0. And let's get all the color values from that. So all of the RGB values. So we're gonna basically extract RGB from that very first pixel and send it over to this pixel. So we're gonna set the first pixel in our pixels array to that same color as the image. And then because we have our nested loop, that's just gonna happen to every single pixel. So we're gonna then go to the next pixel and we're gonna get the RGB from that, which, maybe it's still whitish, but who knows? And then we're gonna go set it to that next pixel in our display. So this is basically, we're like mining the color from the image and making it happen on our display. And what this is gonna allow us to do is now that they're all in there, we can start to mess around with the pixels like we've done in previous lectures, and basically be free to manipulate this image in any way we want because we extracted all these color values. So let's go ahead and see how that's going to look like in code. All right, so we have our loop that's going through all the pixels, and we have our index based on that. Great. So now we need to do the part where we're actually extracting all that color information from the image. So the way I like to do this is I like to say, I like to have three variables, one for R, one for G, one for B. So let's say float R, float G, float B. And what do we want to do? So for float R, we want to extract the red color from the image at this particular pixel. So the way processing has some stuff built in, the way we can do this is we can say red, which is a function that's going to extract the red value from a pixel. And then instead of just saying pixels, because pixels index. Pixels is the array for our window for when we draw our display. If we want to look at the pixels that are in image, we need to say img dot pixels. So we are not looking at the array for our display window. We're looking at the array of pixels for our image, for that watercolor image. And we're extracting the red value from it and setting it to our variable called R. Okay, and then we can just do the same thing for each of the other two color channels. So we can say green, we need to get the pixel value from the image pixel array. So we'll use index here. And finally, oops, where'd it go? Okay, we're back. Now we need to get the blue. Blue image pixels. We're looking at our array for the image. And there we go. So now what we should have is for every single pixel, we should have the red, green, and blue value of the image of that watercolor. And now we can use these to set each value of our window to be the same value. So we're basically like transposing the color from the image to the window. All right, so now we'll say pixels. We're back to our window pixels array, not the image pixels array. We're gonna say get the pixel at location index, and let's set it equal to the color RGB. Great. And that's all. So we've extracted all the color. Oops, got an extra slash there. All the color. Extracted color values from image. And set pixel color for display. All right, so let's see what happens if we just run this. And there it is. So you'll note that we're getting the image. This is a little bit kind of interesting to think about. We're getting the image that we expect. But if you notice, we never called the image function. You know, we never said image img00, put it at the corner. We're seeing this image because we grabbed every color value from each pixel, you know, of the entire image and set each pixel in our display here to be the same color. So we basically like put them on a little train. We took them from the image, put them on a train, sent them over to the display. And we have this. And now that each pixel, we know about it and it has a color, now we can do some fun stuff. So let's do some fun stuff. All right, so now that those are loaded, we're gonna use a function called copy. So copy is a built-in processing function. Let's go over to the other screen. Okay. So copy is a function that lets us copy a section of pixels and paste it somewhere else. So it's kind of like on your computer, you do copy and paste, but we can do this with pixels, and we just need to tell it a couple things about where we want to be copying from and where we want to be copying to. So copy kind of takes a lot of arguments, which if you remember, arguments are the things we put inside of the parentheses when we call a function. So the copy function is called copy, and then we have to give it the 6 things, maybe 7 things. We'll see. I know what they are, and we'll find out how many it is at the end. So the first thing we need to know is where we want to be copying from, and specifically, we need to know the top left corner of the section, kind of like the slice of pixels we want to grab. So let's draw this out. So let's say, you know, this is our image. Okay. Let's say that what we want to do is copy this kind of slab is not a great word. This slice, that's not great either. This section, let's go with section. This section of pixels. So what we need to know is the X and Y position of this top left corner. Okay, so that's the first thing first. So we need let's call it x1 and y1. So this is x of where we want to grab pixels from. And we're doing the top left corner because we then want to specify the width and the height of the section of code that, or pixels that we want to grab. So let's say that this width here is, oh, I don't know, what about 10 pixels? So we want to grab a section that's 10 pixels wide, and then let's say we want to do a section that is, maybe we want to copy pixels that are the entire height of the image. So we can say that the height of the section we want to grab is just height. So we want to grab sections of pixels that are at some x and y position, and we want them to be 10 pixels wide, and then the entire height of our screen. That's the section we're going to grab. Great. So that we say, so that'll be, we'll say width. That's this, the width of the section we want to grab, and the height. Okay, so those are the first 4 arguments we need. Now what we need is the location x and y of where we want to put those, that section of pixels, and also the width and height of that section. And I'm going to, for now, keep the width and height the same between where we copy and where we paste, but we'll change the x and y location. So in this case, we also need to tell it the destination, x2 and y2, and we still need to tell it a width and a height. So this this bit of code takes 8 arguments. It's the kind of the origin, x and y, width and height, and then the location of the destination, x and y, width and height. All right, so let's define all of those, and then let's run this example here. Okay, so first things first, let's define all those variables that we talked about. So we know we need the x and y location of the origin where we want to be copying from. So let's make a float x1, and we're going to get fancy right off the bat here, and we're going to say, give me a random section, or a random location. So random. Now if we want an x value that's random, I want it to be across the entire width of our display. So I'm going to say, give me a random number for x that's between 0 and width. So this is x location of copy. Okay. Now same thing for, we need a y location for where we're copying from. And in this case, because if you remember, we're going to copy the entire height of the image, I'm going to start it at 0. So this is y location of copy. So basically we're going to grab something from some random value x and y, but we're always going to be starting here at the top at 0, and we're going to be grabbing all the way down. Okay, so now we need the width and the height for the section of pixels that we want to copy. So let's make an int called w. Let's say, I think we said in our example that we're going to do a 10 pixel, so width of the section. And then we need the height, so we'll say, how about h is equal to height of section. Oops, I need comments. Cool. Excellent. All right, now just 2 more things. We need the x and y location of the destination where we're pasting them. So what I'm going to do is a little bit of magic here. So I'm going to say that for the destination, for x2, where these things are going, I want it to be basically where x1 was, so basically in the same place, but I want it to be plus or minus some random number. So maybe a little bit to the left, maybe a little bit to the right, who can say? Well, the processing random function can say. So I'm going to say, make our new location, x2, equal to x1 plus random between negative, let's say 10 and 10. Great. Now, if I mean, it probably would make sense to make this a variable, like, you could call it like step size or something like that, kind of like how we did with our random walk function. But for now, let's just say, paste the pixel section at a random value, at a random location up to 10 pixels away from x1. Long comment, sorry about that. All right, now for y2, so the destination for our y location, I'm going to do, I think, kind of the same thing. I'm going to take our y1 location, which was at 0, and now I'm going to add to it that it can be, up to 10 pixels higher or 10 pixels lower than the original location. Same for y. All right, now we've done all these variables. Let us actually put our copy function together. So copy, and we know we wanted to go from, and actually now I'm thinking about it, I think that copy takes ints because we're dealing with pixels, which aren't decimal points. So we're gonna have to go like this, because we, a little bit of a journey here, but because random gives us floats, right? We had to make this a float. And then because copy is dealing with pixel locations, we need it to be integers. So I'm going to use int down here. We could have also done int up here and made this variable an int, but kind of doesn't matter too much for our purposes today. So I'm going to say int of x1. I'm going to say int of y1. So there's our starting location for the copy. Move my mouse here. Now we want int of width. Actually, these are already ints, so I'll say width. Height. Great. And then now we need the new location. So int of x2, int of y2, and then again, width and height. So before we run this, what this is going to do is, as our draw function's going, every single time we're getting a new random location, a new section to grab, and then we're moving it left and right by a little bit. Let's see the result. Very cool. So we see we get this kind of like smearing effect where things are shifting around just ever so slightly. Now we could increase this by changing, how much randomness to the left and right we're doing. We could change how much up and down movement we're getting. So for example, let's make our random displacement here for our destination where we're pasting it just a little bit bigger. What if we do 20? All right, so now we have kind of a greater displacement of these sections of code, sections of pixels. And what I love about this example is I feel like a very compelling sort of endorsement of why fusing together images from the real world or other art pieces like this little watercolor I did, and embedding that into a code, a creative coding context, gives something like this a whole new life. Like, I love the way the watercolor looks on its own because I love those colors. But now I get to treat these, still use these colors, but treat them in a very different kind of digital context that's evolving over time. And I think it's just a really neat way to have a creative practice. So just for fun, let's make the displacement really big. And that will be the last thing for today. So I'm going to say we want our x displacement to be real big, but let's maybe make our y displacement very small. So let's say that we're like actually not going to shift things around all that much. Let's go back to 10. cool. So yet another effect, still within the same realm of idea, but a totally different result just by changing one parameter. This is something that honestly I could just like have projected on a wall somewhere and would be very happy to stare at it for a while. So I hope you do the same. So feel free to go out there and find some images. Go, shoot some photos of crazy landscapes or someone you know, and just see what you can do to mess around with these pixels and have some fun. And that is where we will leave it today. Thank you all very much, and we'll see you next week.